Okay, so high level, this is about how you can process multiple inputs. So what does that mean? Well, let's take a case of most languages, like English. If you want to make a new word, you just do some very simple tasks. You take a word like hold, you add a suffix, make holding. You take run, add make running. Now, that's most languages. You have one input and one output. But in Semitic languages like Hebrew and Arabic, things get different. In Semitic languages, they use templates with multiple inputs. So for example, let's take an word like katab, he wrote or it wrote. It consists of 3 items. Vowels ah, the consonants KTB, and these sort of consonant vowel slots, which does CVCVC. Now, this is an active verb. It means he wrote. If you want to make this word be passive, you can't just add a suffix that could be it was written, but you have to take the word katab and you gotta change its internal vowels to go from katab to kutab. That is, you take this gigantic multiple input system and make it something else. Now, for the most part, around half the continental languages do this sort of processes, and it looks complicated and very nuanced. And most morphological models for these things, they tend to be somewhat tricky to use and not very efficient with these sort of multiple input internal changing systems. So in the last year, me and John, we've been focusing on how, if you want to compute these sort of systems, you have to make a very nuanced machine that can handle multiple inputs. That is, a multi-tape system. Which basically says, well, given some vowels and some consonants, and these CV syllable position slots, you just have to run your machine in parallel all these 3 different things, and then it works. So, long story short, Semitic languages that can be modeled efficiently and wonderfully. Why? Because you just have to make your machine be sensitive to having multiple inputs. And when you do that, you can make your machine be sort of like an n-gram model, but just over very nuanced machines. The end.